moving beyond Excel and becoming more data sciencey. My name's Tim Wilson. I'm the Senior Director of Analytics at Search Discovery. We're going to talk about my journey kind of along that sort of path. So we'll start off with a little bit of a story, a fairy tale, if you will. Once upon a time, there was an analyst. That analyst was me. And I had a deep and abiding and long-standing relationship with Microsoft Excel. We had indexed, matched, VLOOKUP, pivoted, sliced our way to adding some real value to our stakeholders. We'd done some great visualizations, we'd produced dashboards and reports, we'd automated things, and it was really a pretty solid and strong relationship. But about 3 years ago, back in mid-2015, I started to question the merits of that relationship. Was this really it? Was this all there was to it? Was this kind of where I was going to be for the rest of my career? And I started to think, maybe not. Maybe it was time to kind of explore some other avenues as an analyst. And so I decided that I would become a data scientist. And to me, that meant that I was going to do some magical things with the data. So I started digging into what would that look like? How could I become a data scientist? And I pretty quickly realized that I would probably never be sort of a true data scientist. It was unlikely that I was going to go back and get an advanced degree, and there was just so much stuff to cover. But just that little bit of investigation still had me pretty intrigued. So sad that I couldn't be a data scientist, but still kind of excited about some of the things that I realized that data scientists could do. So kind of moving beyond the world of spreadsheets, and this was Excel or Google Sheets, and they're going to be around for a long time, maybe forever, and I'm still going to use them. They're still going to be value, but what else was there out there? And there were certainly BI tools out there, but specifically what I'd gotten interested in this kind of world of data science exploration was the programming languages like R and Python, which people were starting to talk about, and it seemed like they were doing some pretty interesting things with them. The world of statistics, which while I had taken some statistics classes, I had never really managed to, and I'd done fine in those classes, I had never really managed to actually apply kind of true or deep, meaningful statistical techniques to the digital analytics data that I was used to working with. And I realized that if you put the programming with data, kind of R and Python, together with statistics, you got into this other area of machine learning, which there were a lot of people talking about and pretty excited about. Wasn't really clear exactly sort of where it fit. But then there'd also, especially technology vendors, started saying, oh, machine learning, that sounds sexy, but we can make it even better. We can go into advanced machine learning and get into this world of artificial intelligence. And I sort of knew that there probably was potential out there, but it was going to behoove me to actually understand some of this R and Python, or the programming area, the statistics area, to actually, if I really wanted to be a part of that sort of future. So I sort of had the realization that you don't have to be a master chef in order to make a good meal. So maybe I could start doing some data science, if not actually becoming kind of a true, with the formal title and a blessing and a robe and whatever halo floating over my head that it would take to be the magician of a fully fledged data scientist. Of course, that starts with trying to figure out what is data science. We have to kind of answer that question. And the only thing that everyone sort of agrees on when it comes to defining what data science is that it's a blending of multiple disciplines, which means it often gets represented as a Venn diagram. And that's interesting, but what are the circles in those Venn diagram? And that's where it's kind of all over the map. As a matter of fact, back in 2016, there was a post on KD Nuggets where the author went through and actually did a survey of all of the Venn diagrams that he could find that were explaining and defining data science. And there were many of them. Some of them had similarities, but some of them were really quite different. Well, one of the things that this whole exploration and this journey has taught me is that I need to get more comfortable with uncertainty. So the way we're going to kick this off is we're going to use a Venn diagram that I think is, I've got about an 85% confidence level of that this is a good way to accurately represent data science. So as George Box kind of famously said, all models are wrong, some models are useful. This is not a perfect definition. I don't really want to have that argument, but I think it's a useful way to look at it. And what we're going to think about is, what if instead of kind of marching towards the nexus of all three of these areas, what if we pursue each one independently or in parallel? Well, we may actually stumble into the intersection of two of these circles. We may actually wind up in the middle and find ourselves doing some data science, but I'll contend that we actually can add a lot of value just pursuing each one of these independently. So we'll start off with subject matter expertise. Frankly, I kind of feel like we've got this. For those of us coming from a background in kind of digital analytics for years and years and years, we've recognized how important it is that we actually understand how the data is collected. Well, we have to sort of have an understanding and knowledge of JavaScript and jQuery and the document object model. We have to understand what the metrics mean, how to interpret them. We've also realized that we can't use that knowledge. We can't go to our stakeholders and talk about just bounce rate and conversion rate or time on site, heaven forbid. We actually have to have an understanding of where they're coming from, our stakeholders, an understanding of marketing and the challenges they're facing in digital marketing, because we actually have to be focusing on business problems and business questions, not just on crunching the data. And ultimately that leads us to being able to effectively communicate results back to them. So we've spent a lot of time trying to learn and understand how to effectively visualize data, how to actually put together the results of an analysis in a way that we can pull all this together and it can be comprehended. So the reason this is a circle in kind of the Venn diagram that we're using is because that's actually a gap for a lot of actual data scientists or people operating the data science world. And that's because it actually tends to take time and experience and kind of learning outside of the realm of, say, computer science or statistics. So there is actually a lot of hand-wringing in the data science community where there are, brilliant data scientists who can do pretty impressive things, but they struggle because they say, I can't, I go to talk to my stakeholders and they kind of duck and run and try to avoid me. I don't feel like we're actually having the same conversation. It seems like we're speaking a very different language. So that's about all we're going to say about subject matter expertise, because in general, I think the digital analytics profession has actually done a pretty good job of trying to figure out how to do this. So that's subject matter expertise. Let's move on to computer science. And when we're talking about computer science, we are primarily talking about Python and or R. And SQL also falls into this, but Python and R are very similar in that they're both these text-based programming languages with which we can do a lot of things with data. And a Venn diagram of kind of their relative capabilities is more of an overlap than it is a separate circle. So of that Venn diagram is highly overlapping because they have very, very similar ultimate capabilities. Different approaches, different syntaxes, different roots. But at the same time, they actually have a lot of commonalities and a lot of similar strengths. So we're going to talk about three aspects of when we talk about programming with data, what we get that really does kind of move us definitely beyond spreadsheets, and in some cases really kind of beyond BI tools as well. And that's going to be connectivity, automation, and data visualization. So on the connectivity front, it really is about inputs and outputs. Where are we getting the data from that we're going to manipulate? Where are we pushing out the results of whatever work we did with the data? So, and whether this is R or Python, they're pretty much going to be the same on this front. That our inputs are essentially infinite. So we can bring in data from an Excel file. We can bring in from Google Sheets, which is basically using an API. Any modern platform, software platform, has an API. Now there are varying degrees of the robustness and the speed and the level of documentation, but when you're working with like an R or Python, a lot of times there's a lot of documentation or there are packages developed to kind of ease the working with an API. So we can pull data directly from our web analytics platform. We can pull data directly from a social media platform. You name it, kind of the sky is the limit. So we bring the data in, and then we need to, crunch it, manipulate, do stuff with it. Well, we can't go to our stakeholder and give them, say, oh, here's the program. Here's the code, right? They don't want that. So we have to actually push the data out. And similarly, we have a lot of capabilities, a lot of possibilities. We can push the results out into an Excel file or back into Google Sheets, or we can push it back into our web analytics platform, or we can generate a report that's very polished and put it in a PDF or embed it in an email or put it in an HTML presentation. We can push from R into a PowerPoint file if we need to. We can build kind of a little mini web-based app that actually is hooking back to the underlying data, whether it's all the way back through the API to the source or whether it's to some kind of temporary data repository that we've provided that kind of web-based interface is working with. So there's a ton of flexibility. And I sort of, when I think about working in spreadsheets and the connectivity that they have, they're plugins, right? If we're using Adobe Analytics, you have Report Builder. Well, that brings Adobe Analytics data in, but that's really kind of it. You have to look somewhere else to say if I wanted to bring in other data to supplement it. Supermetrics has kind of, made a whole business on saying we are going to hook into a lot of common platforms, but still, what happens if you have one other platform that they don't have a module or a plugin that's kind of built for that? You really kind of have to say, ooh, what am I going to do? Do I have to go get a different proprietary software? Do I have to code something extensively myself? So I just feel like when we're programming with data, there's a lot more flexibility. You just kind of think through, where am I going to pull the data from? And we'll look at some examples of this in a bit. So that's really kind of it for connectivity, because it really is sort of a foundational piece. In and of itself, there's no value, but we'll see how it kind of bubbles up in a lot of other applications and uses. So on the automation front, it really does come down to that computers don't get bored, they don't get tired, they don't make mistakes unless we program them to make mistakes. So when it comes to a tedious task or a repetitive task, or even one that just requires kind of some brute force crunching through some stuff, we can have the machine do it, and it's just way, way faster, cheaper, more reliable, lower risk than having a human being do that. So it's actually, automation is one of the things that my first real success with R, where I said, oh, I've done something using this programming language that is genuinely useful to me in working with a stakeholder, had to do with automation. And really it had to do with a question, and this was a client that had Google Analytics Premium, Google Analytics 360, and they had a ton of different websites. They had a bunch of different brands, and each website had its own Google Analytics property, and then there was kind of a primary view in each one. And they had a roll-up property as well, but that wasn't going to kind of meet the needs of the request. And the question had come and said, hey, can we pull like this little set of metrics across each of our sites and look at them side by side? And that would have been extremely tedious to go through like 75 different GA views and actually do that. But I could do it with code. And more recently, and this has happened because I'm in sort of the consulting world, I've had several clients over the past few years where that sort of request or need has come up. And the most recent one was just a couple of months ago. And if we go back to a kind of our connectivity diagram, it was specifically pulling Adobe Analytics data using R and then pushing it out into a comma delimited file that was just a simple spreadsheet. And in that case, it was an organization that had 475 different report suites. So a multinational organization, a ton of websites, and they knew that some of these report suites probably weren't even being used anymore because it was a long-standing Adobe Analytics implementation, but they didn't really know which one. And so the question was, well, can we just get visits and page views for each one of those just for the last like 30 days? And that would be brutal to actually do just in the Adobe web interface or even with Report Builder, right? It would be kind of murderous to do that. But with really only 13 lines of code, and I know this looks like 50 lines of code, but I'm not going to count the comments and the blank spaces and some of even the line wraps. There are really only 13 actual commands here. And what this does is it uses my credentials and logs into their account and says, give me a list of every report suite. And then for each one of those report suites, just go in and pull the total visits, the total page views, and put that into a single comma delimited file, sorted descending by number of visits. And so that's what it pushed out. So this was actually useful, and we weren't really surprised to find that about 20% of those report suites actually had no data in them. And then from kind of a reusability, we went back to this script and started kind of extending it and saying, okay, now we've got a subset of report suites that actually are getting data. Now let's start looking a little bit deeper. Do they have the same configuration of their EVARs, the same expiration and allocation? Do they actually have values in those EVARs? Do we have some of the report suites that, yes, the variables are set up and yes, there's traffic coming in, but some of their core variables are just unspecified is the total value. So it enabled us to kind of iterate back through. And it wasn't like it's magically that it could pull this data from 475 report suites in like 10 seconds. It actually had to crank for an hour or so. The current Adobe Analytics API, I mean, there's a much faster one coming, but the historical one was relatively slow, but it's also cranking through 475 different things to pull data. So, but I didn't have to sit and watch it. I could just kick off the script, and when it was done, there sat my comma delimited file saved to my desktop that I could then, open up and work with. So, that's kind of the automation piece. The data visualization piece is where really maybe it starts to get a little more interesting and a little bit more fun. And obviously we can do everything with that we could visualize with Excel. If we want to do a bar chart or a time series chart, we definitely can do that. So for this, I'm going to focus more on things that really would be really, really hard or impossible to actually visualize coming from a spreadsheet environment. So one example, and this is, again, not really an analysis one, but it was one that was recent. And I started to realize, yes, this is the sort of thing that now that I've gotten comfortable with R, I sort of jumped to very, very quickly. And we had a client that had a whole bunch of systems. And they had 85 different systems that all had some sort of data in them. They had data feeding between the systems. And they said, we struggle to actually figure out what our entire ecosystem looks like. We know we have a governance challenge, but we don't really have a good way to manage all of that. Well, one of my colleagues, a guy named Alan Hyman, went through and dug through all their documentation, did all these interviews, made the spreadsheets, which was still kind of a little cumbersome to really manage and digest. And I'd never done a network diagram, but very quickly, and it took about 2 hours for me to go from nothing to having this working, was an interactive network diagram. That now they're kind of extending and using that to say, okay, we can start understanding where the real critical points in our network are. We can start figuring out what sort of orphan subsystems we have and operate off all of that. If you're interested in this, pretty much everything I mentioned, there's one link at the very end that has links to sort of codes and examples and descriptions. So this was just fun because network diagrams are kind of fun and cool, and I never actually had a case to really generate one. Another example, but certainly could not do that in a spreadsheet, was Twitter followers. And I don't do a ton with social media, but there are times people still use it. It's still an effective channel. And I had a client once who they'd hired a thought leader person who had a ton of followers, but he was shifting roles with the new company he joined. And so the team was saying, who are his followers? Can we just get some understanding of who they actually are? He'd gone from a very global role to one that was very, very US focused. And so in that case, again, it'd be tough he had thousands and thousands. In this example, I just kind of swapped it out with my name instead of, or my username instead of the client's. But I've kind of run it with Michael Helblings, I've run it with MoKiss. And the idea is, okay, we've got Twitter. Let's use R and go to the Twitter API, because Twitter's got a pretty well documented API, pull a list of all of the users of that, all of the followers of that user, then go through that list, hit up the API again, and pull just the basic publicly available information. How many followers do they have? How many times have they tweeted? Where are they? Put all that in one big table, and now I've got a table of data that I can do some pretty basic visualizations with. So I can just do a scatter plot, pick whatever metrics I want on the X and Y axis, just to kind of get a handle. Who's wondering who that one dot all the way out? I'm like, I got Barack Obama following me. Yes, I also have Anthony Scaramucci following me. No idea why. Also have Mixmaster King following me. He's another one. I had to Google that, and I'm still a little confused as to who he is. But that was clearly a let's go follow everybody, and a lot of them will follow us back, and that will boost our follower count. But if you think about, so that scatter plot, kind of interesting, but what am I going to do with it? Well, when it came to who are the followers, well, part of what comes back through that API is sort of all of this profile data, but in a structured text-based format. So one thing we have is the description. How do people describe themselves? And with some very, very, very light text mining, I can't just take all of those. One, getting all of that through Excel would be tough. Just throwing it into a word cloud is not going to be useful. I've got to do a little bit of cleanup. So just a handful of commands. Remove punctuation, remove the stop words, the a, and, of, the. That's kind of one command. Remove numbers, shove everything to lowercase,
It's like 5 little simple operations that are pretty standard kind of pre-text mining operations and then generate a word cloud. Not super interesting for me. This just kind of validates that it works. Yes, I am in digital marketing analytics, but it actually says, okay, that makes sense. The few thousand followers I have, they're in the area that I'm in. It was actually much more interesting for the client because it was much more kind of diverse and scattered. And we could move on beyond that and say, let's start doing some real text mining. Let's just do a bag of words analysis, do some n-grams. Maybe we start clustering the followers based on how they describe themselves. So we could jump off and go much, much deeper, which I'm not going to talk through today. But this is the sort of thing that Wordle has been. In Excel, it's kind of like do a bunch of formula cleanup and then throw it all in Wordle, and you're kind of limited. Whereas when you're programming with data, you have a lot more flexibility. Where are these followers? Well, Twitter, everybody puts in a free text field. And we can look at it as humans and say, okay, Boston, MA. I intuitively know that is not in Germany, right? Google Analytics says most places. So what is a way for us to say, where are these? We're not being asked as Twitter users to put in our latitude and longitude, because we don't even know what that is. But if we think about Google Maps, it does exactly that. We type in, and if you give it something like Boston, MA, it says, oh, I can pretty much figure out you're thinking Boston, Massachusetts in the US, and it can return a latitude and longitude. If you ask Google where is most places, it'll basically shrug. If you have no location, it will shrug. So you can't get all 5,000 followers, but a good 90% of them, chances are Google Maps and the geocoding API, it's another system, another platform that I've hooked into, just expanded that data table, and then can do some kind of useful visualizations that start to look like kind of what some of the BI tools do, except I've actually managed to pull the data in a customized way and then actually show it on a map. Or maybe I actually want to make it interactive so somebody can mouse over it and maybe even zoom in. And maybe even I made a guess as to who might be here, who's following me. Come on, Jen. Watch it. What? I told you Jen Kuntz was going to be in it. There you were. So, but that's kind of handy, and that's not an enormous amount of coding once we're comfortable with it, and it was kind of exactly the sort of thing we were looking for. Being able to identify without sort of just scrolling through a list of followers, very, very handy. Okay, but we're at a Digital Analytics Association event. We probably should have one sort of pure web analytics example. This is a little bit less of the visualization and a little bit more of just being able to manipulate the data. But if we're doing content marketing of some sort, it's pretty common to say, I'm rolling out a blog post, or I'm rolling out new content, push it out on social media, and it gets a big spike in traffic, and then you hope it's amazing traffic, amazing content, so it never dips off, but it almost always drops off. You hope it doesn't drop off precipitously, but it's going to be out there, it's going to live out on the long tail, and hopefully still add value to your organization for a while. But it's hard if you just take, these are 2 blog posts released about 6 months apart, which one of these has done more for the company? Kind of hard to say just from looking at them. Maybe I want to take and deduce when the launch date was and plot them instead of when they actually happened in time. Let's just look at the first 60 days or the first 90 days. And I don't know exactly when these posts launched. I just had to get the machine to say, look, for each one of these, go and look at the first day that it had real traffic, and let's infer that that's the launch date. And then just look at the first 60 days or the first 90 days of that. So now I get to where I can compare them a little bit. They actually look pretty similar. But maybe I could do one more visualization and say, maybe I just want to look at total traffic that has come in and viewed that content over time. So let me make it a cumulative traffic. And now I can start to look at it and say, OK, 21, 22 days in, that blue blog post was actually generating. It seems to kind of continue to be contributing a little bit more data. You turning off the doorbell sound?
That's the air conditioning unit. There's nothing we can do about it. So.
The little ding is the air conditioning unit?
Oh, the ding, that's something on a computer.
Oh, interesting.
Yeah.
Oh, OK. Oh. You're not turning off the air conditioner.
No.
OK. Woo! Because I am cranking out some hot air here. OK. So that's just sort of what we did. Well, what if we looked at it at scale and said, why don't you look at all of the blog posts and give our marketers something that they can look at and they can mouse over and they can start to see which of these posts that may have released a long time ago are continuing to generate traffic. We should go back and revisit those, make sure the content's current, make sure we have a good, strong call to action on it. And maybe we start filtering out the ones that are really, really low. But it's hard to imagine when I wrote this, and there were people who said, I've done that in Excel. It's kind of tedious. It's kind of formula nightmare. The code for this is actually reasonably straightforward and reasonably shareable. So those are kind of 3 examples of visualization. We've talked about computer science and automation. Hopefully there's something in there that you thought, wow, that would be really cool. I can think of how I could apply something like that in my work. But does that mean I have to learn R or Python? And that's actually sort of 2 questions. The first question is, do I need to learn like one of these 2, regardless of which one? And I'm going to say the answer is yes. If you're in analytics and you're not planning to retire within the next 5 years, it behooves you to learn one of these. There's a ton of things you can start doing with data that you just can't do in a spreadsheet or in a BI tool or even in Data Studio or Analysis Workspace. As cool as those are, there's stuff you can do that is not reasonable to do in those other types of platforms. Even if you don't wind up using those, working with the people who are. You'll be almost certainly working with data scientists or with analysts who are using this, and it's just like being comfortable enough with JavaScript and jQuery and the DOM. Even if you're not doing implementation, we need to understand the data collection. It will just make you more effective when it comes to working with the people who are using those, because you'll understand, you will have gotten your hands dirty. But there is a learning curve. So the other question is, okay, if you buy into that, then which one should I learn, R or Python? And that is kind of, it depends. The Venn diagram of what both of those can do has a ton of overlap. Their roots are kind of different. They're both open source, so they're free. They're supported by huge communities. They're both very mature. There's a post that I've got a link to in the link at the end by a guy named Alexandros Papageorgiou, who wrote kind of a comparison. And he sort of goes through and says, these are kind of the relative merits of each one. He comes from kind of a digital analytics background. He lands kind of slightly on the side of R, but the post is really, really good about saying, but if you're in this condition, this situation or that situation, Python might make more sense. Really, like where I'm trying to head is to actually get fluent in both. That's the ideal, but that's also not really reasonable. This is, again, not a take one course on Coursera and you're totally fluent in either one. It takes some practice. So that was the computer science side. But that was just the computer science. There was no real data science going on. That's just kind of programming with data. So let's talk about the statistics side. That's actually a bigger deal. And to me, it's a lot harder, and I'm a lot less as far along in my journey as I would like to be, and I'm still grappling with it. But what we're going to do is talk about one really, really big point that if you take nothing away from this presentation, hopefully you retain that one point. But we're going to do it in the guise of a very, very simple, straightforward example. How many people know who Annie Duke is? Retired professional poker player. I could not have less interest in poker in any format. Vegas, sitting around a table, smoking cigars. But Annie Duke is becoming one of my heroes. So she is retired. She has a fascinating kind of story how she got into poker. But she's got a new book out called Thinking in Bets. And I heard her a couple of months ago on the Slate Money podcast, and she made this statement. She said, we have a problem in America with thinking probabilistically. That's a very profound statement. And I think we can actually replace that and say we have a problem in marketing with thinking probabilistically. We are kind of in search of the truth. We think we have more data, we have these fancy platforms, that it's going to actually get us to the answer. And we're actually never going to get to the answer. So we're going to come back to that, but hopefully I'm going to convince you that that is a big deal and maybe change the way you're thinking a little bit. How many people have a degree in statistics in here? Anyone? Okay. Oh man, it's got to be the front row person. Okay. If you need to shout, liar, at some point, feel free.
Long ago, I don't use it.
Okay. Well, get back to it. So we're going to start with the world's simplest example. Has anybody not answered this question? Raise your hand if you've never had to answer. How much traffic came to the site last month? Okay. And simple question. And so we're using sessions as a metric. We could use really any metric. That's not material. I'm just trying to start. The metric is super, super simple, starting with a super, super simple question. We had 2.5 million sessions or visits to the site last month. We always want to have some context for that, so we may say, well, let's look at how it trended over the course of the month. Let's look at it kind of by day, or let's look at it by how it broke down by what channel it came from. So also something we've looked at a million times. Well, here's where we're going to start digging in a little bit and maybe doing some things, thinking about it a little differently from how many of you have historically thought about it. Ask a simple question of how many rows of data went into this table. and it's not really meant to be a trick question. We've all seen the table in Google Analytics or Adobe or in Excel, right? It's 7 rows of data. We sort of know, we're visualizing it to make it easier for the stakeholder to consume, but we know what the data looks like under the hood. If we ask a data scientist who doesn't have the subject matter expertise and hasn't been using Google or Adobe for years and years, how many rows of data went into this, this chart, they would look at it, ponder it for a minute, and say, well, each one of those bars represents a whole bunch of individual observations or individual sessions. So in their mind, they would say, I think there are about 2.5 million rows of data. And each row is a session, and each one represents, each one has what channel did that come through. So this is a very, very loose subset of what Google BigQuery integrated with Google Analytics looks like. But that's kind of a profoundly different way of looking at and thinking about the data. But I took, embarrassingly, it was about a year where I was going back doing the statistics world, and I was reading Statistics in Plain English and the comic book guide to statistics. I'd taken a couple of statistics classes, but I would pivot to the digital analytics data and say, I can't get past the first step. If I'm looking at my 7-row table, and I say, okay, what's the variable in this? Well, I'm not sure if it's channel or sessions, but maybe channel. I'm interested in channel. Okay, what's the values of the variable? And then kind of hurt my brain. I'm like, well, it seems like paid search, organic search are the values, right? But then I don't have any sort of scale, so that doesn't feel right. Are the sessions the value of my channel variable? Well, then I don't actually have which channel is, and I literally had these exercises. Is it somehow combining the channel and the number of sessions? Like, surely the value isn't paid search underscore 8188993. And I just couldn't figure it out. And so talking about doing various regressions or any statistical technique, and I'd look, I'm like, what is my actual variable? If I look at the 2.5 million row version, it actually is pretty easy. Yes, channel is my variable. And my values are actually the different possible values of organic search, paid search. They just occur, paid search occurs 818,000 times. That's a real pivot in thinking. And kind of having, the way I grew up in digital analytics, this was actually a hard way to start thinking. And I feel like the digital analytics industry is conditioned to thinking this way. If we're ever working with the Google Analytics web interface, we're working with aggregated data, not the detail stuff. That's not, I mean, it's deep under the hood, but we're dealing with dimensions and metrics. Same thing with Adobe Reports. Same thing, if we hook Data Studio up to a Google Analytics view, we're working with aggregated data. If we're using Analysis Workspace in Adobe, we're working with aggregated data. If we're hooking in, using R Python, hooking into the reporting API for Google or Adobe, we're still specifying dimensions and metrics. As long as we're working with dimensions and metrics, that's aggregated data. And ultimately, the more you dive into the space, we realize that that's got some real limitations. We're not going to get to the world of machine learning with aggregated data. Google and Adobe have both tacitly kind of acknowledged this. Back when Google Analytics Premium came out, and they said, oh, one of the things you get with this is you can hook your Google Analytics straight into BigQuery and get the detailed data. And a bunch of us, I was definitely one of the misguided ones, was like, yes, finally Google is addressing the sampling issue. It's expensive, but I won't run into sampling anymore. That was like a secondary incidental artifact. The big news is they were making that detail, the 2.5 million row type of data available. Now more and more people are using it, and they're pulling data from that so they understand it. But Google sort of saw that coming, and they did a really good job of making that integration work. Adobe has had the data feed forever. And they've just been making it easier and easier to access, so that if you're an Adobe Analytics admin, you can sort of specify your data feed, and you can then push it to whatever, if you want to push it to Spark, Hadoop, BigQuery, wherever you want to go, you can push it there. It's Adobe, so it's still unnecessarily painful and clunky, and the sadists inside Adobe are continuing to make people suffer. But once you get the data, it's actually in a workable state. You can actually work with it. I feel for anybody who's kind of been working with the Google Analytics version and they switch to Adobe and they're like, what were these guys thinking? I'm like, they really want you to understand how the sausage is made. So if you look at the more modern analytics platforms, if you take, like, just for example, Snowplow, Heap, one of the sponsors today, from the get-go, because they didn't have the processing limitations that the older school platforms had, From the get-go, they say, no, we are capturing that detailed data, and that's kind of our first way that you're going to access it. Yes, we'll enable you to aggregate it as well, but we're thinking detailed level data first. So that is the way the industry is shifting. OK, so now is every example from here on out going to be you must be using GA360 or using Adobe's data feed? No, I think we can still do some interesting things statistically, even if we're just using Google Analytics Free in our simple little example of aggregated data. So no, we can actually still maybe get some interesting intuition. We're going to cheat a little bit, and I'll call out when we're actually cheating, but it actually works pretty well. So we're going to ask a different question, which is we're going to go back to our same table, but we're going to ask, does channels really impact the number of sessions that came to the site? We're all subject matter experts, so I don't know of a site where channel does not impact the number of sessions. So we already have the answer. We know the answer is yes. Channel impacts the number of sessions. I'm not talking about the quality of sessions. Again, the metric is actually immaterial. Even if we didn't really have the subject matter expertise, we could probably eyeball it and say, yeah, for the most part, these are different enough that it does seem like channel seems to be a factor that affects the number of sessions that are coming to the site. Maybe not for email and referral, but those are kind of lower volume anyway, but the difference is a little bit less. So we can look at that and say, yes, we're going to eyeball it, but that's still subjective and relies on a human being. How do we make it a more objective assessment of whether channel impacts the number of sessions? Well, one, if we drill down and said, let's combine, look at time series by day, and look at channel, then things get a little murkier because I could look at this and say, wow, depending on exactly which time frame I pulled, the actual order of sessions, the number of sessions, the order of the channels may actually differ. So there's a little messiness. Plus, this is just a messy chart to look at. But what I've done here is I've converted my one metric, my one totally aggregated 2.5 million metric, into what's actually 210 different data points, right? Because I've got 30 days and 7 channels. So each channel I have 30 days. So I have 210 channel day combinations, 210 observations. So here's where we're going to start to cheat a little bit. And what we're going to do is we're going to use day as our observational unit for our analysis. And first we're going to check and say, you know, it doesn't look like anything's like really trending up over the month or down over the month. It seems reasonably stable. There are some spikes and dips. But for the most part, we're going to be OK with this cheating. But what we're going to do is we're going to ignore the time aspect of data. We have 210 data points, but we're going to stop caring about the fact that paid search, the second day of the month, occurred after the first day of the month, and the third day of the month occurred after the second day. So we're just going to say we have 30 observations for each channel. We're going to start by saying we just have 210 observations of the number of sessions. And that means we can actually look at the data instead of as a time series chart, we can look at it as a histogram. So what this is saying is that of those 210 channel day combinations, there are like 52 of them that had between 0 and 5,000 visits. Of those 210 observations, there were 33 or so that had between 5,000 and 10,000 observations. We don't tend to look at histograms. This is starting to look like a distribution, right? This is a distribution of the observations. But we've all had enough statistics to know that this is not a normal distribution, and we know we want a normal distribution at our core. We can actually, instead of looking at the bar chart where I had to pick a bucket of 5,000, we're going to do what's called a density plot, which is just another representation. I've removed the y-axis because it's not that important for this, and it becomes less intuitive. But that's just a smoothed out version, right? This is my histogram. You can sort of see that's showing the same distribution. And it clearly is not a normal distribution. Instead of doing it for all 210 data points, I could pick just one channel. I could pick social. I could look at a bar chart. I could look at a density plot. Now I have something that, even with only 30 data points, is starting to look kind of normal. And that's one of those kind of miracles of statistics, how you can quickly get to things that are normal without an enormous amount of data. OK, so this is kind of audience mental participation point. We're going to do some physical transformations of this overall distribution. So the first thing we're going to do, you need to all sort of think through what this is going to look like. We're going to mirror it over like mirror it across a vertical axis. So it's going to just flip horizontally. Everybody have in their mind what that's going to look like? OK, did I lose anybody? Don't admit it, because that would be embarrassing. That was the easy one. The next thing we're going to do is I'm going to rotate it and squish it. So I'm basically going to take it and I'm going to shove it up over against the left-hand side. I'm not changing any of the data, I'm just changing the way that it's being displayed. Okay, everybody still with me? I'm going to go back for anybody who looked down at their phone temporarily, and we're going to rotate it and squish it. Okay, so this is my 210 observations. But what I'm going to do is I'm going to break that out 30 at a time for each one of the channels and do that same flip and then rotate and squish. Have in your mind what that might look like. Well, this is what it looks like. This is kind of exciting. I got kind of excited when I actually did this the first time. No, I don't have a life, and we got that. But these are all kind of close to looking sort of normal. We have a normal distribution. We like to drop a mean on it. It's going to be somewhere near the middle. That's kind of cool. Now I can start analyzing. I can look at by channels, how far apart are those means, and how big is the spread of that distribution. And again, we know the answer that yes, channel number of sessions varies by channel. But this is a way to visualize that says, yeah, I can look at even looking at the spread of those distributions, those means are far enough apart that I can intuitively say, yes, I'm analyzing the mean and the variability of each of these channels. So that's actually what a one-way ANOVA is basically doing this, but doing it kind of with numbers and code behind the screens. You can do a one-way ANOVA in Excel with the analysis tool pack. You can kind of do it in any tool. You give it like these 210 observations. It's going to split back some pretty easy to read results. We can look at that and say, okay, we can clearly reject the null hypothesis. It's like, what the hell just happened? We had these nice visualizations. We were moving along, and man, we jumped into statistics speak and stats land. And it does take a little getting used to think, why are we doing this null hypothesis thing? And this is where I think a lot of us have been conditioned, and our stakeholders, to say, just give me the answer. Answer the question, do channels differ by sessions? And we say, no, we're going to reject the null hypothesis. What is that? Well, the null hypothesis is generally, there's nothing to see here. That's kind of the basis of the null hypothesis. No matter what we're looking at, we're going to start by saying, no. Our null hypothesis is no. Which channel it is does not impact the number of sessions. So if we're rejecting that, then we're saying, yes, sessions do appear to differ by channel. But now there's some disappointing news. This doesn't actually tell us which channels differ. So that's kind of one macro statement. But what if I want to know which channels differ? Well, I can do some additional analysis. Analysis after the first analysis. Or why not pull up a dead language and use Latin and go with, is Latin a dead language? Is it considered dead? It's not spoken? It's considered dead. OK. So we're going to do a post hoc analysis. Just a fancy way to say we're going to do an additional analysis. And we're going to do one that's called a Tukey post hoc analysis, which kills at cocktail parties. But this guy, John Tukey, came up with it. And the idea is that the way that we rejected that null hypothesis was that one number is basically the p-value in this less than 2e. That's effectively 0. So it's a very low p-value. We can reject this null hypothesis. The Tukey post hoc does a similar thing, but compares each channel to each other. So we could look at it and say, now we're looking at every comparison of channel. And this is like reading one of those old road atlases where you've got two cities and the intersection is how many miles apart they are. So email and social has a p-value of effectively 0. We can reject the null hypothesis that email and social drive a different volume of traffic. And that's pretty much the case for all of those channels, except for email and referral. And this is where we go back to sort of the intuition. We can't reject the null hypothesis that email and referral basically drive the same number of sessions. If we go back to our visualization and look for email and referral, and we start thinking about the mean and the variability, look, the mean's very close. And with their distributions, we would expect those to maybe kind of bounce back and forth. Maybe there is no difference between email and referral. By the number of sessions, clearly differences in the quality and the type of traffic. So that's kind of cool, I think. And it leads back to our bigger point, which is we started looking at distributions. And distributions are a measure of variability. And if you think about what variability is, it is kind of a way of quantifying to say, tell me the truth, and to kind of forget about the fact that we're operating on uncertainty. OK, but I have more data. Doesn't more data reduce uncertainty? It does. It can. But there's a cost to that. Data collection, data storage, data manipulation, data modeling. But that's what we do with more data is we reduce the uncertainty. Well, what if we had like infinite data, like AI? If I just throw all my data into this fancy data robot, it's going to take it and it's going to give me the answer, right? No, we can't eliminate uncertainty. And the actual cost, the incremental cost to reduce uncertainty and the amount of uncertainty we can reduce varies by situation. I will claim this is not how the digital analytics world, because we're pleasers and are working with marketers, we want to get to this simple truth, and we're not actually getting there. So it's a very profound, different way of thinking about data, what we can do, how we make decisions, factoring in cost. And that's data scientists kind of operate in that world. They start using terms like confusion matrices and expected value criteria. So you've all been lightly Matt Gershoft. I promise you if you read one of his posts, I actually have stickers that say I've been Matt Gershoft. So if you've ever been Matt Gershoft and you like stickers, see myself or Michael Helbling. We also have podcast stickers, so we're moving into the 2018 branding world. But definitely go check out some of his stuff. If you ever have a chance to see Matt speak, I highly, highly encourage it. So we were exploring those circles kind of independently. And there's a lot of value. Hopefully you've got some ideas of, wow, this is valuable. This will actually help me deliver more value to my stakeholders. Well, if you start exploring these independently, just even accidentally or consciously, occasionally you'll stumble into that intersection of all three. And you'll find yourself actually doing some data science. So this is one, so Jamarius Taylor, who's at SDI. I did not do this. This is a k-means cluster analysis. We've got a client that has a bunch of franchises. This is kind of an unsupervised learning thing where you start saying, let's take a bunch of data and run it through this analysis. There's some Euclidean distance and nearest neighbors and other kind of fancy words going on. But tell me how to kind of group those, which is kind of the cousin to how can we kind of organically just figure out the natural segments in our data. In this case, looking at these franchisees to then take those clusters and say, okay, now we're going to dig in and start looking for specific differences between these clusters and start understanding some of the fundamental differences between our different franchisees. Is that about 80% accurate? Okay, I'll go with 80%. Here's a larger, kind of longer stumbling into data science. And this is a propensity modeling thing that we do with a number of clients. I'm not here selling it. It's just really exciting to me because I had very little to do with it. Ken Williams is here. If you have specific questions, see him. Ken started down a similar journey that I did, although like a year or two later, and he made it much farther, much faster, which I'm a little bitter about and questioning whether I drank too much in my youth. But what this does is it takes a bunch of data and it throws it into BigQuery and it does some modeling, kind of training and prediction. And then what comes out of it is for every user on the site, it provides a probability that that user will convert. And there's a lot we can do with that. We can bucket it. We can feed it back into the web analytics tool and say, now we have something to segment on that's kind of a generated dimension. We can use it to say, we don't want our chat bot or our chat hooked to a real customer service person popping up for everyone. Let's only show chat for potential customers. Let's feed it. Let's use our remarketing. Remarketing is expensive. Let's do remarketing, not remarket for users that we have a very, very low likelihood of purchasing. So there's kind of the sky's the limit, and there's a lot of potential. And this is actual data science. But I want to call out exactly what's happening there because it actually encompasses everything I've talked about in this presentation up to this point. There's no aggregated data. We're only working with data that is user-level data. So this is pulling BigQuery or the BigQuery integration with GA or Adobe data feed. That's the data it's using. So that's important. That integrating the data inside of BigQuery, that is done with Python and SQL. That's a computer science component. Actually doing the training and prediction, that's Python, and it's applying statistics. Right now it's gradient boosting, so way more advanced than kind of an ANOVA. And then guess what? This whole thing, propensity modeling, you know what propensity is? It does not spit out this person will convert and this one will not. It only spits out a probability. And unless we're comfortable with recognizing the world of type 1 and type 2 errors and the relative cost, this is actually useless. So this is like the big point of the entire presentation is kind of fundamentally built into this. So it all comes together. There's a lot of value operating individual circles, then all of a sudden you stumble into and realize you're doing something at the intersection of all three. And I think that is really, really exciting. So where to begin? I literally gave Michael Helbling one task last night, which was to take a picture of me in front of this slide. Because this is the guy I drink with on Thursday nights, drink Guinness, and it got called out that this picture had never appeared in one of my presentations. So Michael is going to actually randomly text this guy and say, is this you? This exists on a urinal cake in Dublin, Ohio. Like, I've got stories. So there's lots of places to dive into this. There are courses. So I've got one link, pretty easy, bit.ly data-science-e. All the code examples, there's the code is there, resources to books, Annie Duke's book, Matt Gershoff's blog post. Try to keep it to stuff that I have actually used and gotten value out of. One exception is I've got sort of the MOOCs and the online learning. I'm really excited. edX has recently announced they've got some partnerships. So Georgia Tech, I found out this morning that Maddie's actually in the Master's in Business Analytics program through Georgia Tech through edX. Super affordable. It's like $10K to do some of this stuff. And you will get into R and Python and statistics and all of this stuff. So check it out. Thank you very much.